Taking a little bit longer than usual. There we go. Okay. So this was the problem we dealt with last time. We finished up with the first derivative test. We found out the critical points, and we found out when there is when the function is decreasing on which intervals and when it's increasing on which intervals, and also if there's any local mins or maximums that are involved there, right? So that's that right there. After that, we took the second derivative, right? And we were about to work on figuring out any possible points of inflection, right? Do you guys remember that? The second derivative test doesn't tell us about when the original function is increasing or decreasing. Instead, it just talks about concavity, right? Whether something is concave up or concave down is when the second derivative is either positive or negative. If the second, I'm going to say this again, if the second derivative is positive, meaning you plug in a value into the second derivative, that means at that particular point, the concavity of the function is concave up. And you can do it for intervals of points if you're looking for when they're equal to 0 or not. Sorry, you're late. Don't worry about it. You got it just in time. We just started up. We're continuing where we left off last time, right? On this problem right here. 2x to the fourth minus 16x to the third. And we're going to go ahead right now, and we took the second derivative right there, and now we're going to solve this for when it is equal to 0. Okay? When does this second derivative equal to 0? Well, they have a common factor here, right? They both have an x term, so I could factor out an x term from here. And they also have a factor. Does anyone know what's the common factor between 24 and 96? Do you guys know if 24 goes into 96? Monica's saying 24 does go into 96. Monica, I'm going to trust you on that one. So I can factor out a 24. That's going to leave me with just a single x for that first term. And I'm going to cheat and use my calculator and see if 24 times what is going to equal to 96. 96 divided by 24. I should be able to just do this, shouldn't I? It should just be 4. I don't know why I doubted myself. But yeah, so 24 times 4 is going to give me that 96. So what's left behind is x minus 4 right there is equal to 0. And again, I'm going to pause here along the way here. Does anyone have any questions so far? All I'm doing is some algebra and solving, right? You have multiple ways of solving quadratics. Sometimes you might need a quadratic formula. Sometimes you might need to factor. In this particular case, I'm factoring using a common factor, right? No x method, no box method needed for this one. All right, so what are my possible points of inflection? What are my possible points of inflection? Well, 24x equaling to 0 leads me to tells me that a possible point of inflection is at x equals to 0. And then the other one over here, x minus 4 is equal to 0, tells me that I have a possible point of inflection at x equals to 4. X equals to 4. So just like the other one, right? Just like the other table we have up here, right? I'm going to do it for these guys right here. This right here is x equals to 0, and the other interval is going to be x equals to 4. This time, though, these guys are not called my critical points. These are called my possible points of inflection. Possible points of inflection here at x equals 0 and x equals to 4. So what intervals do we end up creating when we have these three possible points of inflection? We have here the interval that's between the two of them, 0 to 4, and then we have the intervals that are around them, right? So this one right here is going to go from negative infinity all the way up to 0, and this one's going to go from 4 all the way off to infinity. Okay? I'm going to go from 4 all the way off to infinity. All right. After that, we just take numbers and we plug it in to the second derivative to see if it's concave up or concave down, right? And this is the part you got to get the hang of. When I say you pick a number, right, you just pick a number that's on these intervals. So in this particular case, I had picked -1 because that's between negative infinity and 0. I picked 1 from 0 to 6, and then we picked 7 from 6 to infinity. And I took those numbers and I plugged it into the derivative, the first derivative. Down here, I'm going to do the same thing, but I'm going to be plugging it into the second derivative, right? So I don't know, guys. You guys pick a number for me. What's a number that's between negative infinity and 0? What's the number that you guys want to do? -1. Monica goes with that. Someone else give me a number that's between 0 and 4. Anyone? 1. Good, good. And one last one. Give me a number from 4 to infinity. 5. 76. You know what, Brian? I'm going to go with 76. Because why not? Is it wrong? We could also go with 7. We could also go with 5. The point is, when you find out a possible point of inflection, that what we're saying is that the signs are not going to change no matter if you picked 5 or if you pick 7 or if you pick 76. Any of those numbers will tell you what the signs are doing on this interval, because the fact that at x equals 4, that's the x, and at x equals 0, that's the only places where the derivative is equal to 0. That means everywhere else, I'm sorry, the second derivative is equal to 0. That means everywhere else, the numbers are going to be, they're all going to be either positive or negative, and they're not going to change, because the only way they can change is if they pass through when the second derivative is equal to 0. So technically back here, when we pick -1, I could have picked -1,000,000,000, and it should still work the same. It should still give you the same sign. All right, so again, I'm going to plug this in here. I'm going to plug it into the factored form, because like I said, when it's a little bit easier to see the sign, because that's all we really care about. We care about the sign. We don't actually care about the numerical value of this. We just want to see if it's concave up or concave down. All right, so if I plug in, let's say -1, I'm going to have here 24 times -1 times -1 minus 4. Right? So we check this out here. I'm going to have a negative sign right here times another negative sign right there. And a negative times a negative tells me, of course, that this is going to be a positive sign, which means that on this interval, we have something that's concave up. Concave up. That's it. Go to the next one over here. Plugging in +1, we have here 24 times 1 minus 4. 24 times 1 is a positive number. 1 minus 4 is going to be a negative number, and I'm going to end up with a negative sign. Again, I don't care what the value is. I just care that the value is negative, which tells me then that this point right here is concave down. Right? Concave down. So you can actually see it's changing concavity numerically. I know not see it graphically, but I can actually see it, right? On this interval from -infinity to 0, it's curving downwards, right? I don't know if it's increasing and curving downwards, which is a possibility. It looks like that, right? Or it could be decreasing and concave down, which will look like that, right? And we'll figure that out when we combine this information with the first derivative. And then, oh, I'm sorry, the concave up. So it could be looking like that, or it could be looking like that, right? Both of these are concave up. But we'll figure out if it's increasing or decreasing when we combine it with the other one. And then that goes from concave up to concave down. So right here at x equals to 0, we have a point of inflection that actually does change from one concavity to another. Okay? And then we're going to go back over here, and we're going to finish this off right here. And yeah, we're going to go over here and write this one down right here. This is going to be 24 times 76 times 76 minus 4. And again, I only care about the signs. This right here, 24 times 26 is positive. 76 minus 4 is also positive. So my remaining sign here is positive. So this is going to be concave up on that interval. Right? So that's pretty much the idea here. Where's this function concave up? It's concave up from -infinity to 0 and from 4 to infinity. This function is going to be concave down from 0 to 4. Okay? So that's our second derivative test, right? So we have here our first derivative test and our second derivative test here. What I'm going to do now is take these intervals and combine them together. I'm going to pause and let you process that for a second here. I'm going to make a sign chart, right? I'm going to make a sign chart. And I'm going to combine the two intervals together and see what they're doing on those sign charts. And then with the sign chart, I'm going to be able to combine them and see what the overall function is doing for all these particular intervals. This is going to look weird at first, but you're going to see what I'm kind of doing here. Okay, so check this out. If you look here, the intervals on the first derivative goes from -infinity to 0, then 0 to 6, then 6 to infinity. The intervals down here kind of overlap that with one particular problem here. It goes from -infinity to 0, but then it goes from 0 to 4, and then it goes from 4 to infinity. Do you guys see the overlap that we're going to have right here? Right here, it goes from 0 to 6. Well, right here, it goes from 0 to 4, and then it goes from 4 to infinity. So that 0 to 6 right there needs to be split up into two parts of this interval here. So let me show you what I mean, what I'm trying to write out here on this one. So let me draw this out. If you guys want to take some time and draw this out as well here. Actually, can I just insert a table? 5 across, 3 down. No, you're not gonna let me do it that way? No, that's ugly. I'll just draw this by hand. All right, let's go. So let's say I have here the intervals that I'm going to be dealing with, right? Check this out. The intervals that I'm dealing with, right, is going to be from negative infinity to 0. But here's the thing. I normally would go from 0 to 6, but I'm going to go instead from 0 to 4. And then I'm going to go from 4 to 6. And then I'm going to go from 6 to infinity. I'm going to pause there for a second. I'm going to let you guys look at the intervals that I just created right here for the sine chart I'm going to make. Pause there for a second. Can you guys see it okay? Now, who's got questions on how I got these intervals right here? Be honest with me. Who's got questions on what I did? This is the time to ask, because if not, I will move on. But I need to know, are you guys okay with this? Does this make sense on what I just did? A lot of people tend to struggle with this, so don't hesitate to ask. There you go, Max. 0 to 4 and 4 to 6, right? So here's the thing. On the first derivative, I know my interval is going to be from 0 to 6. On my second derivative, the interval I care about that I'm focusing on is from 0 to 4, right? So I put 0 to 4 up there, right? But then I don't go straight from 0 to 4, then go to 4 to infinity, right? I still need to look at the interval between 0 and 6, right? So I can't go straight there because 0 to 6 was an important interval for the first derivative test. So I need to look at that, and that's this guy right here, right, from 0 to 6. So I can't just ignore this right here. I can't just go, oh, I'm just going to go from from negative infinity to 0, and then from 0 to 6, and then from 6 to infinity. I still need to focus on the 4. So I'm kind of combining these guys together, right? So let me write this out a little bit further. Here are the intervals that we're dealing with, right? Maybe we can do this right here. So check this out. On the first derivative test, right, we care about it from negative infinity to 0, 0 to 6, and 6 to infinity. Okay? On the second derivative test, I care about it from negative infinity to 0, 0 to 4, and then 4 to infinity. I need to combine those guys together into one chart so then I can see what all of these things are doing. Okay? What all of these things are doing. When I combine where the intervals are telling me where it's increasing or decreasing, where it is concave up and concave down. Okay, so if it's a little bit of a struggle, don't worry. We're going to practice making this table. We're going to practice plugging in those sine charts, and we're going to practice all of that, right? So here's maybe one of you guys would actually be able to see how this is working out. This part right here, I'm hoping that you guys can see it. This part right here, from 0 to 4, is being kind of squeezed in right here. That's where this interval is coming from 0 to 4. It's this guy right here. Now, 4 to 6, I can't just jump from 4 to infinity because I need to focus on this guy right here, which is from 6 to infinity, right? So I need an in-between part between 4 to 6, and that's what this part is coming into play. It's the connection between this guy before it goes off to infinity and then this guy going off to infinity, right? So it's going from 4 to 6 to help capture what's happening between that the critical point and that point of inflection. Does that make sense? That's where that 4 to 6 is coming from. And then once I get to that 4 to 6, I can just go ahead and move on because after that, both of these functions go off towards infinity, right? Both of these intervals go off towards infinity that we are looking at. And that's where I'm getting this from. Are you guys okay with that, or are you not okay with that? Does that make sense? Does that make sense? Because I haven't even gotten to the part with what we do for that part yet. I need to make sure you guys are okay with how that interval comes in right there. Are you guys okay, or are you not okay? It's basically combining all the interval information that we were given before. So real quick, let's just, we can just practice one real quick. So if I was giving you guys, for example, I gave you guys 2 intervals and I gave you guys 3 intervals and I asked you guys to create a table that incorporates those important values. So if I had something, for example, let's say I was going from negative infinity to negative 3, right? And then and then it went from negative 3 to positive infinity, right? And then I had another point down here that went from negative infinity to negative to 0, right? And then down here it goes from 0 to infinity. Would you guys be okay with this? This right here. This is, let's say this was my first derivative, right? And then this was the intervals for my second derivative. If I was going to make this into a chart, right, my overlapping intervals would be from, right, I take a look at which one it's going to stop at first. So it goes from negative infinity up to negative 3. So I'd go with that one first. So negative infinity to negative 3. But then I don't go from negative 3 all the way to infinity. There's a point that I need to hit. And that point I need to hit is at 0. So the next interval would be from negative 3 all the way up to 0. That way I incorporate the 0, right, with my intervals here. And then after 0, I can make my last interval, which is going to go from 0 to infinity, because that's what this one's doing as well. So this will be 0 to infinity. Does that make sense on how to make that table? Like how to incorporate these things overlapping with each other? That's all I'm doing, by the way. I'm just looking at this part, right? So I incorporate that into that. Yeah, it does? Okay. Once we do that, all right, once we do that, the next thing we need to do then is include all the signs and where all the functions are increasing, decreasing, concave up or concave down. Okay? So here's my sign chart, right, that we took this effort to do. And then we look at the sign values for the first derivative on this interval and the second derivative on this interval. Okay, I'm going to look at those sign values of what they're doing on the first derivative and what they're doing on the second derivative. So we have these already here, right? So on the first derivative, right, on the first derivative, let's do that in red right here. On the first derivative, what is the sign of my first derivative from negative infinity to 0? I go and I look and I see it right here. From negative infinity to 0, right, from negative infinity to 0, my first derivative is negative. Right? My first derivative is negative. Yeah. And I keep going here. Now, this is the part that gets a little tricky. What's my sign, right? What's my sign for 0 to 4? From 0 to 4, the sign there is also negative, right? And you'll say, but knock me, that says 0 to 6. And that's okay. 0 to 4 is inside 0 to 6. And if that sign is decreasing and it's negative, then it's still going to be decreasing here. And then we'll get the second half of it right here from 4 to 6, right there. From 4 to 6 will be the second part of it, and it's still decreasing. So the signs are still negative, 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 right? It's negative from negative infinity to 0. It's negative from 0 to 4, and it's negative from 4 to 6. But here's where it changes, right? Here's where it changes. When we go to 6 to infinity, the signs are now going to be positive. The signs are now going to be positive. Now, this is nothing different, right? We already had these signs. We had the negative here, we had the negative here, we had the plus here. The only thing that we had to include in here was that part for the 4. And you'll see why we do that in a second here. Because now we're going to go down to the second derivative right here and get the signs for these intervals for the second derivative. Okay? What is the sign when we're going from negative infinity to 0 for the second derivative? And you guys can see that, right? That's right, Monica. It is positive. It is positive. Right there. You see that? From negative infinity to 0. Now, what is the sign from 0 to 4? Right? The sign from 0 to 4 is going to be negative. So you see, all we're doing right now is we're getting the information that we found earlier, and we're just organizing it into a nice table. And you'll probably wonder why, and I'll explain why in a second here. The next part is going to be from 4 to 6. 4 to 6 is actually included with this 4 to infinity. It's just not going off all the way to infinity yet. So from 4 to 6, the sign is positive, right? Because that's what we have right there. And then when we go from 6 to infinity, that's the rest of this part right here. The rest of this part right here, which is also positive and concave up. So that's all I did. I took this information, I combined them into a single chart, right? So we can see what the original function is doing. Based off of these signs. And you're going to say, like, this just looks weird to me. And it is a little strange. We're just taking all the information that we got earlier, right? So knowing that it's negative, negative, positive, that's what we got right here. Negative, 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 positive, right? And then we did the same thing for the second derivative. So with that, check this out. Okay. If I know that the first derivative is negative, what the? My OneNote's doing that weird thing again. Hold on a second. Give me 1 second. What the? Uh-oh. Hello? Give me 1 second, guys. All right, let me go back over here. There we go. All right. Okay, so here's the thing. If I know that on the interval from negative infinity to 0, my first derivative is negative, that tells me that the original function, f of x, right, the original function is decreasing. It's going down on this interval, right? And since the second derivative is positive, it is concave up. So here's what this would look like, okay? If the function is decreasing and concave up, it's going down, but it kind of curves up like that. Except it doesn't curve all the way up. It curves up like that, right? It looks something like that. That's what a function looks like when it's going down. And then once it reaches 0, we have a point of inflection, and we also have a critical point there, right? All right, at x equals 0, we have overlap there. X equals 0, we have a critical point, and we have a point of inflection at that point. So it flattens out at x equals 0. And then from 0 to 4, the function is still the derivative is still negative, but now the second derivative is negative as well. So not only is this thing decreasing, but it's also concave down. What does that look like? Something that's decreasing is going down like this, right? But for it to be concave down, it needs to curve down, so it looks something like that. You see that? So the function that I'm drawing right here could look something like this. That makes sense? It's decreasing, and then it changes from concave up to concave down right there. Okay? Keep going. Look at this stuff, and we're going to analyze it all the way through here. From 4 to 6, the function is still decreasing, right? The function is still decreasing, but now the concavity changes here, right? The concavity changes from concave down to concave up. Remember, what does that look like when something is decreasing and concave up? It looks something like that, right? So if I were to continue this graph, it should be doing something like this. Right down here, it might be going down like that, right? And then after that, it reaches my critical point at x equals to 6, which now changes it to increasing and concave up still. The concavity does not change after 4. It stays up after 4, after 6, and so on and so forth. So when it's increasing and concave up, that looks something like that, right? That's increasing and concave up. So that means the graph down here might flatten down at the bottom there and then start going up instead. And that critical point right there, if you remember, at x equals 6 was a local minimum, right? We calculated that to be a local minimum. So this is what the graph might look like right here. I don't know, I don't know where it's located vertically, or if it's really high up or really low down, but it looks something like this, right? That's what I can tell you, that it is decreasing concave up, and then it changes to decreasing concave down, and then decreasing concave up to increasing concave up. And that's what this graph is a possible look like, what it possibly looks like, right? So we have here at x equals to 0, right? We have a critical point where it flattens out, the tangent line flattens out. And you also have a point of inflection where the concavity changes from concave up, right, to concave down right there. You see that? And then right here at x equals to 4, x equals to 4 is not a critical point, but it is a point of inflection. And you can kind of see that, right? With my drawing here, you can see it changing from concave down to concave up. You see it? And then at x equals to 6, you don't have a point of inflection, but you do have a critical point, right? You do have a critical point where it actually changes signs. So the tangent line there is flat, just like the tangent line here, it's flat, but it actually changes signs. So it goes from decreasing to increasing, which created this critical point to be a local minimum, So that's a combination of all the information that we got. And now we can actually see what this graph is kind of looking like without actually, we can actually sketch it based off of the information that's there. And we could also double check our work, right? Double check our work and check it into Desmos and see how close are we to this thing. So let's go over to Desmos real quick, my favorite graphing app, right? Or you could do it on your calculator as well. TI calculator works just as fine. But I'm gonna go ahead and graph this guy. And when I say I graph this guy, remember the original problem was not this derivative right here or the second derivative. The original problem was right here, 2x to the fourth minus 16x to the third. So let's go ahead and graph that. 2x to the fourth, 2x to the fourth minus 16x to the third. So here we go. Wow, it's super wide though. You see that? It goes all the way down here to negative, what is that number? Negative 864. So let's adjust these numbers real quick so it makes it easier for us to see here. So let's go from like the highest one was 6, right, for our intervals, and the lowest number was 0. So let's go with like -4 all the way up to, let's say, like I don't know, 8, right? Like so. There we go. And there's our graph. Not too bad, right? Not too bad. If you look at my graph, right? Whoops, that's not my graph. If you look at my graph, right, which looks something like that, right? You see it going down, concave up, and then down, concave down, and then it changes to down, concave up, and then it starts increasing after that, right? Kind of looks like this, doesn't it? See it? It's down, concave up, and then at x equals to 0, we have a point of inflection right there where it changes from concave up to concave down. And then at about x equals to 4, right? Can you guys see that okay? It changes from concave down to concave up, but it's still decreasing, and it's a very subtle change there. It's a very subtle change there. And then, right, at x equals to 6, we had a critical point down here as well, and that critical point turns out to be a local minimum, right? A local minimum as it changes down there. Anyways, how do you guys feel? You guys okay with this? Does it kind of make sense on what we just did there? We were able to see a general shape of this graph just by looking at these sign charts. Was that only one problem? No, Max, it was a combination of a lot of problems in one. Most problems will just ask you to find where is the function increasing, where is the function decreasing, where are the points of inflection, where are the local max or local mins. I combine this into one ginormous problem because it's an idea of like, you can connect all these things together. There is a connection between you finding out what is a derivative and what is a second derivative, and what does that entail, right? And it will help you with different things. But yeah, Max, I wouldn't give you, I might give you one problem that was this long just to see. But the thing is, it would be broken up. There would be many pieces along the way there, and you'd get a lot of points along the way because it's asking for a lot. It's asking for you to find the first derivative, the second derivative, and all that and so forth. Let's see here. Let's practice another problem. Yeah, I say that one problem is not enough. We should practice doing this next problem here. So yeah, so check this out though. By the way, check this out. This is, I can't help but just be like, thinking how cool this is. So let's pretend this is so let's not pretend. Let's take a look at this function real quick, right? Let's call this f of x. I love this about Desmos, by the way. Check this out. So this function right here is f of x, right? If I were to graph its derivative, we know where the derivative is positive and where the derivative is negative, right? And we also know that tells us where the function is increasing, where the function is decreasing. And I need you to check out how neat this is. So this blue line, right, is a graph of the derivative, right? This blue line is a graph of the derivative. And if you look closely, right, the blue line is negative from, right, from negative infinity all the way up to 0, which is exactly what we found right here in our table. From negative infinity all the way up to 0, the derivative is negative, right? The derivative is negative, okay? And if we go back over here, right, and then from 0 to 6, it's still negative, right? From 0 to 6, it's still negative. And you can see that. It's down here. It's negative. I don't care that the derivative itself is decreasing. I just care that the value is negative. So it's negative whatever here, negative whatever there, that means that the original function should be decreasing on that interval. And that's what it's doing. If I go from negative infinity all the way to 0, it's decreasing, 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 and then it's not decreasing anymore. And then after that, it starts to decrease again. You see that? It starts to decrease again, and it goes all the way down to here, right? Until it reaches x equals 6. And on the derivative, after x equals 6, you see here the derivative is positive now, which tells me that the original function should be increasing. We talked about analyzing a function and its derivative graphs before, right? And you can see it. Where it flattens out is where the derivative is equal to 0. That's what I always taught you guys to look for when you're looking to see what's the function and what's the derivative. But now we can go even further and look at values for these guys, right? If it's a positive value here, that means the original function is increasing. It doesn't matter that it's negative. It's still increasing. It's still trending this way, okay? And then if you go even further, and look at the second derivative, right here, and let's not look at the derivative here, and just look at the second derivative, right? You can see here on the second derivative, it's positive all the way up to 0, which means that the second derivative is telling us that the original function is concave up all the way up to 0. And then it's negative from 0 to 4. Are you seeing that interval right there from 0 to 4? It's negative right there, which means that it's concave down from 0 to 4, right? It's concave down from 0 to 4. So these are the intervals. Let's actually get these intervals in there. So x equals to 0, right? X equals to 4, right? Let's get these all to be, let's get them all to be the same color. Let's go black and dotted there. So you can kind of see it. On those intervals, you can see, right, it's concave down from 0 to 4, and then everywhere else from negative infinity to 0 and from 4 to infinity, it's concave up. It's concave up, you know? And I think that's kind of neat. And then if we do the same thing with our first derivative, you can see where it's increasing and decreasing. And if you look at that for x equals to 0 and x equals to 6, right, for this problem. Check this out, check this out, check this out. Are you checking this out? Check this out. Right here and right there. You can see where the function is decreasing, right? So from here to here, it's decreasing because it's negative, and then from here to here it's decreasing still because the derivative is negative. And right here where it's going up, the derivative is positive. So it shows you that the function is increasing. Anyways, I know I'm getting like long-winded into this talking about this, but it's just neat once you actually see the connections between a function, its derivative, and its second derivative. I know it's like there's a lot going on there, but it's just neat to do. I say it's neat to do. All right, so this next one is going to be a long one again, so I'm going to ask you guys for your help. So you guys are going to help me do this problem here, okay? So let's go over here, and let's do a new problem. I'm going to ask you to do the same thing that we did up here, which is find the intervals where the function is increasing or decreasing, concave up and concave down. Okay, you notice it doesn't even ask about making the sign chart or graphing it, but you know I had to show you guys this. We have to practice that. And don't worry if you don't get it. Like I said, it was one go. We're going to keep trying until it makes a little bit more sense, okay? So I'm gonna go down here. Let's do it for the same. Let's do the same thing, but for this problem right here. Let's look at this guy right here, and I'm gonna be asking the same thing from you, which is tell me, where is the function? Find the intervals where the function is increasing, decreasing, concave up, and concave down. I'm gonna clear your pair deck, and you don't have to show your work. You don't have to show me the first derivative and all you plugging in and whatnot. Can you guys tell me on your pair deck, right? Tell me. Just write it down like this. Give me the intervals where it's increasing, right? Give me the intervals where it's increasing. So you could write it down like this. So write down increasing and then give me, you know, however many intervals there are, like if it's from negative infinity to 0, and then from 0 to infinity, or from 0 to 6, right? Just give me those values like it is right here. So give me these guys, right? So that's where it's decreasing. So if I were to write that down, that would be my decreasing values. And then this right here would be my increasing, right? So on this one, on the pair deck, I've cleared the screen out for you. I'm going to give you guys about, I'm going to go with like 8 minutes because this requires a lot of time. So tell me where it's increasing, right? Tell me where it's decreasing. Tell me the intervals where it's decreasing. Tell me the intervals where it's concave up. Concave up. And tell me the intervals where it's concave down. Okay. Tell me the intervals where it's concave down. Let's go with, like I said, let's go with about 7 minutes on this one because it is a lot that I'm asking from you guys. But I think you guys can do it. I think you guys can do it. So tell me where it's, where these intervals are, where it's concave up, concave down, increasing, decreasing. That's it. Okay. And after that, I'm gonna have us. We're gonna double check all of our intervals. Okay. So get those down. Yeah, get those down. So let's go ahead, set a 7-minute timer. Knock me. What are you doing? 7 minutes. Okay. So on this right here, on this function, tell me. Where's the function increasing? Where's decreasing? Where's it concave up? Where's it concave down? Give me those intervals. And if you have more than one interval, just tell me which one's which. Remember, do the work in your own notes. You don't have to do the work on the pair deck. Just give me your final answers of where are the intervals for it increasing and where are the intervals for it decreasing. Okay. Yeah. Oh, one person's already got the first interval for where it's increasing, and that looks right. That looks right. Beautiful, beautiful. Ooh. Looking good. Looking good. All right. Looking good, guys. Oh, I see more answers now. Beautifully done. I'm gonna pause the timer. Looks like that was just enough time for a lot of you guys to get the first derivative test done. I like it. So that's some work that's done. Have to restart. Don't worry about it. I'm gonna increase the timer. So 7 minutes might not have been enough. So let's reset it. Get you guys another 7 minutes. But that was enough time, it looks like, for most of you guys to get the first derivative test where it's decreasing and increasing, or at least giving me those intervals. So keep going, guys. Keep going. Don't stop now. Keep going. That's beautifully done. Beautifully done. Beautifully done. Beautifully done. Beautifully done. Oh, dog was barking. Hold on a second. Okay. All right. Do-do. All right. Oh. All right. All right, all right. Oh, people starting to do the concavity now. Beautiful. Beautiful answers, though, for the increasing, decreasing. Very good. If you got 2 intervals for increasing, you got 2 intervals for decreasing, you are on the right track. You're on the right track. There should be 2 intervals for increasing and 2 intervals for decreasing. Yeah, I think that's it. Yeah. Is it 2 to both? Actually, hold on. Let me see here. Let me double check. Okay, yeah, 2 to each. That should be right. And then the hard part, second derivative, concave down ones. That's a little bit difficult. Yeah, yep. 3 intervals, I think, in total for concave up and concave down together. I don't know how many. I think it's 2 concave downs and 1 concave up. If you're doing those intervals, if you got that, that should be the right answer. That should be the right answer. I'm gonna steal your answers when we go into this, though. I'm gonna just write them down. I'm gonna just trust that you guys did these correctly, right? That you did the testing of each point on these intervals correctly and whatnot. And I'm gonna just trust you guys that you guys got it done, including the derivatives. Right? I'll write the derivatives down just so you can double check to see that you got the same derivatives that I got. But I trust you guys. I think you guys got this. From what I'm seeing so far, it's looking good. It's looking good. It's looking good. Ooh. All right. Yeah, it looks like you're done. Looks like you're done. Or at least one of you guys are done. Let me check the rest of you here. You're almost done. Ooh. Uh. Hey, David. You there, David? David, can you do me a favor and let me know, does this pop up for you? If I give you feedback for your screen, does this show up on your screen? David, you there? I just wanted to test the feature. You mean in my pair deck? Yeah, in your pair deck. I left feedback for your pair deck. Does it show up on your pair deck? I'm just curious because that's kind of neat if it actually does. Yep. Hey, cool. Also, look at my feedback and be careful with what you have written there. All right, guys, let's go ahead and go over this here real quick. Right. So, turn that off. So let's take a look here. Double check your work and see if you guys get the same answers as me here, right? F prime of x is the first derivative. So you should have gotten, this should be equal to -4x to the third. right, plus 36x. Did you guys get that for the first derivative? Right, that should be the start for this problem, right? If you're asked to find increasing, decreasing, you don't know what to do, take a derivative, guys. All right, take a derivative. That's the first thing that we're going to start this off with. And if you're asked for concave up and concave down, we can go ahead and look at the second derivative, and that's going to be right here. And I would have gotten negative 12x to the second plus 36, right? The critical values or the critical points you should have gotten, right? The critical points that you should have gotten if you were to solve this cubic right here, either by factoring it, or I think that's the only way I know how to do it is by factoring it. You should have gotten that x was equal to 0, x is equal to negative 3, and x is equal to 3. Those are the critical points that I would have gotten for that one. For my possible points of inflection, I would have gotten x is equal to the square root of 3, or x is equal to the negative square root of 3. There we go. So those are my possible points of inflections. From there, you're supposed to do some testing of these intervals that you get to create to figure out if it's concave up, concave down, or if it's increasing or decreasing, right? So for the critical points, for the increasing or decreasing one, right, the function should be increasing from, it looks like, negative infinity all the way up to negative 3, okay? And then it's decreasing from negative 3 to 0. Then it's increasing again from 0 to 3. And then it's decreasing from 3 to infinity. Can you guys double check that you guys got that? That's what you should have gotten for your increasing and decreasing intervals. Right there. Your increasing and your decreasing intervals. All right. Double check, double check. Does anyone have any questions on how I got that? Does anyone have any questions? Need to see how that is the case for it to be increasing or decreasing. All right. You guys okay with that? The intervals that I made, by the way, are around these critical points. All right. So 0 to negative, I'm sorry, negative infinity to negative 3, negative 3 to 0, 0 to 3, 3 to infinity. I should have written these in better order, but you get the idea, right? If I go from descending or go into increasing orders. Wow, English is hard today. Okay, so that's your increasing and your decreasing intervals, right? For your concavity, right, this thing is concave up on the interval of negative square root of 3 all the way up to the square root of 3. Positive square root of 3, knock me. This thing is concave down from negative infinity to negative square root of 3, and then negative square root of, it's concave down from square root of 3 to infinity. Bam. That's what you should have gotten for your concave up and your concave down. That's what you should have gotten for your increasing and your decreasing. And yeah, that's that. How do you feel? You guys okay? You guys all right? Does anyone need to see any of these done? Because if you can do this is a big part of it, like I said. And I'm hoping you're still standing by, Max. This, like I said, this is a lot. If this was a homework problem, part A would be find where is the interval increasing. Part B would be find where the intervals are decreasing, right? And then C and D are concave up and concave down. And then, of course, part 5 would ask you to sketch out the graph. Okay? All right. I want you to do one more thing for me. Can you do increasing, decreasing? Of course. Of course. So what I like to do, Max, when I come across and I get my critical points, I like writing them in order from smallest x value to largest. So I write it out like this: x equals to negative 3. I draw a line. X equals to 0. I draw a line, and then I go x equals to 3. I draw a line. I get my intervals based off of these numbers right here, right? So you got to find those first, and then I make my intervals. So this is going to be from negative 3 to 0. This is going to be from 0 to 3. And then, of course, if I don't have any numbers on the sides of these, that means that they go off towards infinity. So 3 is going to go off towards infinity after that. And then over here at negative 3, it's going to go off towards negative infinity. That's how I got these intervals. See that? All these intervals right here are the ones that check off for these intervals right here. Okay? Now, how do I find out if a function is increasing or decreasing? You pick numbers on those intervals, and you plug them into the derivative if I'm doing for increasing and decreasing. So, for example, if I was to pick a number, let's say between 0 and 3, like, for example, let's say 1, right? Then I'd be testing right here. I'd be testing it into the derivative, right? Which is going to be negative 4 times 1 to the third plus 36 times 1, right? This is going to give me -4 plus a positive 36, which is a positive number, which tells me that this interval right here is increasing. And that's what you're going to do for all of them, Max. That's how they figured out that all these guys are increasing. So based off these answers that I'm double checking with people in the pair deck, right? You do the testing here, you pick a number here, it comes out negative, right? And you can pick any number from like -2, -1, -0.5, -0.4. It comes out that same way for there. And same thing here. If I pick 3, I'm sorry, I can't pick 3 because 3 is going to equal to 0. If I pick 4, right, or I pick 5, 6, 7, 100, a billion, then we get a negative sign right there. And the same thing over here. If I pick -4 or -5 or -6 or -a billion, I'll end up with a positive sign right there. And that's how they figured out that it is increasing here and here, and then it's decreasing here and here. Does that answer your question, Max, on how that came to be? How that is? How is it? Is that all right? Yeah? Okay, Max. Awesome. Awesome. It's a lot, guys. There's a lot going on this one. And in fact, we're still not done because I still want you to get the hang of combining these two intervals together. So I'm going to clear your screen real quick, and this is going to be the last thing I'm going to ask from you guys today, is to create a table that combines all of these intervals together. I'm going to give you so I need you to combine from -infinity to -3, along with -3 to, does it go to 0 or does it go to -√3? Just so you guys know, just so you guys have an idea, by the way, √3 is approximately, what is the √3 approximately? Let's plug that into a calculator real quick, just so we have a reference of what that number is. √3 is roughly 1.73 or 1.76 is what Monica's saying. 1.7, let's go with that. So you know where this is. I'm going to ask this guy, you guys right now, before you leave, I cleared out your pair deck screen. I'm going to give you this hint. There are going to be a total of 6 intervals when you combine these guys together. There's 7 intervals right now if you look at them. It goes from -infinity to -3, right? 0 to 3, -3 to 0, 3 to infinity, and then there's some combinations of √3s in there. So I'm going to tell you right now. Can you guys get this for me right here? There's going to be a total of 6 intervals. So here's 1, right? Here's 2, 3, 4, 5, and 6 intervals. I want you guys to try right now to combine the intervals in question that we have into 6 intervals. I'm asking for a lot, is what I'm saying. I want you to try this. So if you look earlier at my notes, right, we had these 6 intervals right here. We had -infinity to 0, 0 to 6, and 6 to infinity. And then we had -infinity to 0, 0 to 4, and then 4 to infinity. And when we combined those 6 intervals, I ended up with just 4 intervals, right? But it was an ability to combine all those intervals together, right, into this one right here. I'm asking you to do the same thing, but I want you to do it for this right here, for these 7 intervals. And I'm just letting you know right now, I'm giving you guys this hint. It ends up being just 6 intervals, right, when we combine these together. So can you guys do that real quick? Combine these intervals. And I think this is going to be the last thing I'm going to ask from you guys, is to combine these intervals for me. Yeah, this is going to be the last thing I ask from you guys, I believe so. Ooh. I love it. I love it. You guys understand this part, right? The furthest left point should probably be negative infinity. The furthest right point should probably be infinity. All right, those are the ones that it goes from there to there. Oh, wait. Oh, okay. Right? Does that make sense? It should be from negative infinity to infinity, right? Those are the endpoints that we should have there, right? The furthest left is going to be negative infinity. The furthest right is going to be infinity. Now we got to combine the ones in the middle. I forgot working at home, doggo is super acute and distracting. Doggo is super cute and super distracting. You guys want to see Doggo? Don't huff at me. I'm teaching class right now. Yeah. Let me see if I can get her. Kai. All right, Kai. Hold on. Let me see here. Move the camera carefully so I don't lose picture. All right. Kaya. Come here. I want to say hi to you. Oh, you're being so cuddly. Oh, that's all. Did you get breakfast yet? No? No breakfast? I'll get you breakfast after class. Okay. Once I finish class, I'll get you breakfast. Oh, okay. Oh, all right. Oh, no, it's so cute, though. There we go. All right, there you go. You guys got to see Doggo. Yeah. All right. Oh, someone's going above and beyond and giving me the sign chart along with it. We're gonna do that later, but awesome. I see that someone's doing that right there. Oh man, someone's riding in a speed zone right now. Just letting you know right now, Aurelia, that looks beautiful. That speed you got going there looks good. Monica, I'm going above and beyond. I did not ask for the sign chart, but thank you. That is awesome. Putting that in there. Jeffrey, that looks perfect. Jeffrey, that looks perfect. Okay. All right. Good job, guys. Hey, perfect timing for most of you guys. Hope you guys can see this right here, right? 1.73. So check this out. An easy way to do this, right, is basically just go in order for the numbers that you have for your critical points and your possible points of inflection. You ready for that? That's the trick that I would have done here. The smallest number I have for these numbers right here, from -3 to negative square root of 3, the smallest number I have is going to be -3. So that's why negative infinity is going to go up to that. And then after that, I'm going to continue from -3 to the next smallest number, which is not 0, but negative square root of 3, right? And then I'm going to continue from there. I'm going to go from negative square root of 3, and the next smallest number I see on here is going to be 0. And then after that, you just keep going. 0 goes to the next smallest number, which is going to be the positive square root of 3, which is going to go from positive square root of 3 to 3. And then after that, 3 goes off to infinity. And that's your interval right there. So if you guys could copy that down, put this in your notes. And I'm going to actually end our lesson there because it is 10:37, guys. And that's going to be it for me today. I'm hoping that you guys are okay with this. I know it was a lot into one video, and we're going to continue this next week. So don't worry if you don't get it yet, but start practicing. There is homework problems assigned now, and you guys should be able to try these homework problems from 4.3 part 1 and 4.3 part 2. All right, with that being said, I'm going to stop it there. Have a good rest of your day, guys, and I won't see you until next week on Tuesday. There's no school on Monday, so have a great 3-day weekend. Have some fun, but not too much fun. Stay out of trouble, stay out of jail, don't get pregnant. All right, I'll see you guys on Tuesday. Have a good one. Bye. See you guys.